Assalamualaikum students, welcome to the new lesson. It is the revision of coordinate geometry as we have discussed in the previous lesson that the distance formula, midpoint and gradient was calculated and how the lines are parallel, the gradient will be behaving in what way. Today we will be discussing the perpendicular lines, that how is the behavior of the gradient in case of the lines are perpendicular. Two lines are shown over here, L1 and L2. If we consider L1 is having a gradient of M1 and L2 is having a gradient of M2, we calculate the gradient by the method we have discussed in the previous session, that if we move 4 steps right, we can see that we are moving 2 steps up. So it means rise is 2 and run is 4. And as gradient is rise over run, so 2 over 4, which gives us 1 over 2. Now if you consider the line L2, if you move 2 steps right, we are going 4 steps down. 4 steps down means the sign will be negative. That means we are going 4 down. So rise is minus 4 and run is plus 2. So after the simplification we are able to get the gradient is minus 2. Now if you compare both of these, when you take the product of the gradients, 1 over 2 times minus 2 over 1, which gives us minus 1. So we conclude from there that when the lines are perpendicular, the product of their gradients is minus 1. In short, what we do in the questions, if two lines are perpendicular to each other, for example, this is having a gradient of 3 over 4. What will be the gradient of M2? We know M1 times by M2 equals to minus 1. So 3 over 4 multiplied by M2 equals to minus 1, which will be shifted to the other side and we take it as minus 4 over 3. If you see the relation between these two, in short what we are doing, taking the reciprocal of the gradient and changing the sign, which gives us the gradient of the line which is perpendicular to the given one. This will help us in finding the equation of line in different situations. Now, how to go for the equation of line? We need to have two basic things for the equation of line. Number one is the gradient of the line and second one is the y-intercept. Gradient we already have discussed, and how about the y-intercept? It is the point where the line crosses y-axis. The line shown on the graph, you see over there, it is falling. And we should keep in mind when the line is falling, the gradient is supposed to be negative. And when the line is rising, gradient is supposed to be positive. If we calculate the gradient over there, we take 2 steps right, and we see that we are going minus 2.5 steps down. Which says that rise over run minus 2.5 divided by 2, which gives us minus 5 over 4. And according to the situation of the line, we see over here that the y-intercept is plus 3. So by using the basic equation of line, which is y equals to mx plus c, we have y equals to gradient is minus 5 over 4x plus 5 over 2. So to simplify the equation, what we can do, that to remove the 4 from the denominator, we are going to multiply everywhere by 4 and we reach a simplified form of equation in this way. 4y equals to minus 5x plus 10. We can use another way out here, which is y minus y1 equals to m into x minus x1. In this specific situation, we have found the gradient already. We can use any one of the points. Y minus y1, let's say this is the point on the line whose coordinates are 2 and 0. So y minus 0 equals to m. M is minus 5 over 4 and x minus 2. Now you see here that this will be simplified to y equals to minus 5x minus plus 10 divided by 4. And after the cross multiplication, we reach to the same place, minus 5x plus 10. This is how we can find the equation of any line. Now, how do we see different lines and what is the behavior of their gradients? Let us see a situation that when the line is parallel to x-axis and when the line is perpendicular to x-axis. If this is the situation here and this line, let's say it is 2 and the line is passing through 2. This line we know it is given an equation y equals to 2 because if you see here at 1 it is 2, at 2 it is 2, at 3 it is 2, everywhere the y coordinate is fixed. So we are moving towards right. There is a run but we are not going up or down. So in this case, as we know gradient is rise over run. We are having a run but the problem is we do not have any rise over here. So we say that the gradient is 0 in this specific case. The line is parallel to x-axis and gradient of x-axis is also 0. So this line will be having a gradient equals to 0. Now if the line is passing through a point minus 3 and it is parallel to y-axis, its equation will be mentioned as x equals to minus 3 because it is passing through minus 3 and parallel to y-axis. How about its gradient? If you see here minus 3 and 1 minus 3 and 2 minus 3 and 3, you see over here the x coordinate is fixed whereas y coordinate is changing. So the gradient for this is going to be rise over run. So you see here we are not moving towards right or left. So there is no run in this case. And rise may be if you take this point or any other point. So the rise is going to be 1 over 0. So we say any line which is parallel to the y-axis, it is having a gradient undefined. This is all about perpendicular lines and the gradient and the equation of line. Now, we know that these are the basic simplifications. How about the questions when they are coming in the A-levels examination? When the questions are coming, obviously the difficulty of the question will be different in each and every question. But the basic idea regarding the questions will be the same. So we may be using perpendicular lines, we may be using parallel lines, we may be using the equation of a line. In all these circumstances, the basic idea is how to use the distance formula, middle point, gradient, equation of a line, perpendicular lines and parallel lines. I hope this small session will be helping you to revise your coordinate geometry. Thank you.